All right, so we are looking at Algebra 2 Honors and STEAM notes, intervals, average rate of change, and the difference quotient today. And so in the warm-up, we've already completed that, and it's just review of the function notation worksheet. And example 1, it's really review of the function notation worksheet too, but it gets a little more complex in the algebra. And so you have g of x, but they want x to be this binomial, 2t plus 1. So every place you see an x, you need to replace it. And so we are going to have, label what you are doing. You are finding g of 2t plus 1, label it. And every place you see an x, you need to replace it in function g. And don't forget the plus 1. Oftentimes people just kind of skip over that, and that makes errors for that. This process is going to be necessary in the difference quotient that you're going to do today. Now, one big concern I have is how you're going to handle this. The incorrect expansion is 4t squared plus 1. The expansion of a binomial is not another binomial. It is a trinomial. And so I just want to mention that process over here, that when you take 2t plus 1 and you square it, you are taking 2t plus 1 times 2t plus 1. You distribute the 2t, you distribute the 1, and what always happens when you square a binomial, the middle two terms are the same. So I have the saying that to get to the answer, you square the 2t, you square the 1, put it at the end, and then you end up multiplying these two, which is 2t, and doubling it, and you get your plus 4t. And so you can go directly from here to here. By square it, multiply and double it. Square it, multiply and double it. Because that's when you FOIL that out, the middle two terms always match, and it's the product of these two. You've got them twice, so you double it. So when we go to this next line, notice I'm dropping down, not going left to right. I'm going to square the 2t. I'm going to square the 1. I'm going to multiply these two, which is 2t, and double it. Square it, multiply and double it. The square of a binomial is always a trinomial. Then distribute the 2. And don't forget that plus 1. And at this point, you expand and collect like terms. 16t squared plus 16t plus the 1 plus 4t plus 3. Just combining the 2 and the 1, and just continue on. So we have 16t squared, we have 20t, and then plus 4. And that is the result. Yes?
Shouldn't you multiply the 1 by 4 with the trinomial?
Oh, I sure did mess that up, didn't I? Oops. Yay, thank you. I was just seeing if you're awake today. And you asked so nicely, Yep. Sorry about that. Thank you. Thanks for the correction. Silly me. That's why you guys are so smart. I've just done it longer. All right, so moving on. So the next thing that we're going to do is we're moving towards learning the difference quotient. And when we're saying rate of change on a function, we are actually talking about average rate of change. Average rate of change. And average rate of change is simply slope between 2 points on a curve. Average rate of change is simply slope between 2 points on a curve. So when you find the average rate of change, you should be thinking, okay, I need to identify 2 ordered pairs and just find the slope. Slope's something you've done from Algebra 1 or earlier. And so on this graph, we have at A, so if I go up to when x is A, the ordered pair that belongs to it is A, and this is the function f, and so you need to put A into the function f, and that's the ordered pair. It's abstract. It's not a nice, it's 2, 3, it's 5, 7, you know, it's abstract. But that's what we need for a general average change here. So that's the starting point, and then we're going to end when x is b. And so the x-coordinate is b, and then you need to plug that into the function to get the y-coordinate. And so we want the slope between these 2 points. And the slope formula is change in y over change in x. And that's when you have your 2 ordered pairs, your first one and your second one. It is change in y, which is your rise over your run. I've had, every year in Algebra 2 Honors, I've had students put x in top instead of y in top. Let that not be you. And so for the slope, which is your average rate of change, for this, it is ending up being, you know, it's your rise over your run between those 2 points. That's your average rate of change, the rise over the run between those 2 points. So change in y, and I want you labeling it with slope. The change in y, I'm going to do second point minus first point, so f of b minus f of a, all over. Then you do b minus a. You've got to subtract in the same order. I'm starting with the second point, both on top and bottom. And this is your average rate of change as x changes from a to b. On the interval from a to b, that's how we talk about it. On the interval from a to b, this is your average rate of change. And it also happens to be, it is the slope of the secant line. And the secant line is a line that intersects in 2 points. It is the slope of that line. So now it's going to be the same process, but we are going to talk about this as it is known as the difference quotient. Quotient, you know, you're dividing. But in the difference quotient, we use different variables, and there's a reason for that. So we're going to start at x instead of at a. And so that point on the curve is x, f of x. But we're going to do a different way of finding the second point. We are going to go h units to the right of x. And this process allows us to use the limiting process in calculus that makes it a little easier. So we're building a skill that you're going to use in calculus. So that next point is going to be h units to the right of x. So instead of a and b, we're using x and x plus h. So that second point is h units away from x. And so that means on the curve, the x-coordinate is x plus h. And you have to plug that binomial into the function to get the y-coordinate. That's why we did that example where we evaluated a function with a binomial. And now it is your slope. Your difference quotient is the slope between these 2 points. And so f of x plus h minus f of x all over your change in x, which is your x plus h, minus your x. And because we chose x and x plus h, The denominator simplifies. The x's cancel and you're left with h. And that is the difference quotient. That is the difference quotient. And you're going to be using it to evaluate when we get to some problems a little later on in your homework. It's simply slope, right? How hard could it be? It's more abstract, lots of variables, a little different than what we're used to. But welcome to just growing up in mathematics. It's a good thing. All right, so we're going to have some more concrete examples down here. Find the rate of change over the following intervals. Well, you have a function h of x, and this, they said, over the following intervals. These are intervals. These are both x values. These are both x values. As x changes from -2 to 0, what is that rate of change? And it is actually the average rate of change. Now you get to show the work for it. And so the idea is when x is -2, you need to find the y value. And when x is 0, you need to find the y value. And technically, because this is h, it's h of -2, and this is h of 0. But you have two ways of finding the y. They have already given you at -2, the y value is 4. They have already given you that when x is 0, y is 0. So you can just get it from the graph, but they give you the equation, and if you square -2, you get 4. If you square 0, you get 0. So you have options there for figuring out that this is 4 and this is 0. I insist on you showing me the two ordered pairs you're using for slope. And then label and show the substitution for change in y, 0 minus 4, over change in x, which is 0 minus the -2, so it's plus a -2. And you get -4 over 2, which is -2. And if you were to draw a line between those 2 points, that's the slope of that line. It's -2. It's the slope of the secant that goes through those 2 points. All right, you try the next one. I'll do it up here. You do it on your paper. So just waiting while students are calculating those. All right. The idea is these are both x values. So when x is 0, what is y? 0. It's also true if you plug 0 and square it, you get 0. And then when x is 3, what is y? It is 9. And that's true if you plug it in here and you square it. So those are the two ordered pairs, and then it's just change in y over change in x. And simplify, and you get a slope of 3. Again, if you were to draw a line through those 2 points, the slope of that line is 3. So one last one, just going to work through it very quickly. At -2, the y value is 4. At 3, the y value is 9. And so for the slope, you get 9 minus 4 over 3 plus 2, which is 5 over 5, which is 1. And that's your average rate of change. So average rate of change, you're going to show me the two ordered pairs you're using. You're going to show substitution into slope. You are going to label it as m equals and simplify and box your answers. All right, backside. They want the average rate of change. And it says between 1 and 3. So these, again, these are x values. So it's on the interval as x changes from 1 to 3, what is the average rate of change? They just give you it's the same thing, they give you the information differently. They don't give you the graph. They haven't pre-figured out what the y coordinates, but they give you the equation. And so you are going to need the point when x is 1, and you're going to need the point where x is 3. But you need to show that you are plugging in 1 into h to get that value, and that work should be on your paper. Even if you can do it in your head, you're communicating your process to me. So they give you the equation so you can plug it in. Sometimes I've seen them give you a graph without an equation, and the only thing you can do to get the y coordinate is look at the graph. So just different ways to give you information. And so when x is 1, y is 2. When x is 3, y is 26. So for the average rate of change, it is slope change in y over change in x. And you get 12. Notice the equal sign as I move down. Box in your final answer. And then when we get to example 4, you're going to be evaluating the difference quotient that we were developing on the first page. But before that, find the domain and range of this function. Well, you should know that's a linear function. Y-intercept is -2, slope of 3. You should already know something about the graph. You should be able to graph that using slope-intercept form of graphing. And so by knowing that's an oblique line, a line whose slope isn't 0 or 1, it's slanted, the domain and range is all reals. Domain and range is all reals. And so -infinity to infinity, -infinity to infinity. Now for the difference quotient, you're going to need to have to figure out f of x plus h. So I'm going to go ahead and do that right down here. And that means where you see x, you need to replace it with x plus h. And it needs to be the whole quantity times 3. Don't forget the -2. So I would have this written down, which it's already written down for me. Then I would drop down with an equal sign and have a fraction bar centered with that. And now I am going to, this is f of x plus h, so I'm replacing this with this. So I'm getting 3x plus h minus 2, and that is my f of x plus h. And then after that, I need to subtract f of x. Well, they gave you f of x. It's a binomial. I need to subtract the entire thing, so I need it in parentheses, minus the 3x minus 2. Minus that 3x minus 2. And that is your minus your f of x. And the whole thing is over h. And now it's a matter of distributing and collecting like terms and simplifying. And so we're going to distribute the 3, distribute the negative, and that is the place I'm always watching. This sign right there, people don't always use the parentheses, or sometimes they use the parentheses and still forget to distribute that negative. It's a common error. And that is all over h. A sign that you're doing this correctly is right now, everything that does not have an h should cancel. If that doesn't happen here, you've made an error. And this 3x cancels with that. The minus 2 cancels with that. And I want you to take the step where you write 3h over h. I don't want everything canceled in one step. Now the h's cancel. And your result of the difference quotient is it is 3. And that is the algebra. That is the format that I want. And you're going to have a linear function where you need to find the difference quotient, just like this on your homework. So use this as a template to help you walk through it, if you need it. Now, the other thing is, just for a moment, think about this. We had the line 3x minus 2. And the difference quotient is all about taking 2 points on it and finding the slope between those two. Rise over run. Well, the slope of this line is 3 because it's linear, so it shouldn't be surprising that the end answer is 3. And it's like, you mean we did all that work to find the slope that we already knew? Yeah. But it's to be able to practice the algebra on something that's a little less complex. It gives you an opportunity to practice something that's a little easier algebraically. But that's the difference quotient is the average rate of change on a line. It's always the same rate of change. So it's not surprising we got 3. Now, the next example, though, is quadratic. It's a parabola. And so its rate of change it's not linear, it's curved. And so at each point, the rate of change is changing. That is why we are doing this. This is the process behind it. And so you're going to have a little more work algebraically to be able to simplify this. And, there's more places to create errors. But the first thing is they want domain and range. Well, as much as I hope you remember what this looks like, if you don't, you put it into the Desmos graphing calculator and you graph this to see what it's like. I'm just going to mention what it looks like. It's a parabola opening up at 3, and since this is positive 2x squared, it opens up, and it's also a vertical stretch, so it's a little narrower. We don't need the exact points, but that's what it's going to look like. And it gets wider and wider and wider. It's a polynomial, so the domain is all reals. But as you go bottom to the top, the range is 3 to positive infinity. So if you're not sure what the graph looks like to give domain and range, you can put it into Desmos for tonight's homework. In chapter 1 in the textbook, you're going to know that's what this looks like. You don't need the graphing calculator to tell you. We'll be doing this a lot. All right, so then we're going to do the difference quotient. And I do want you to, it's not right there, so I would like you to write it here. And then the next line's going to be a little bit longer, so I'm going to leave some space for it. But we need to start by finding this f of x plus h. And if you can accurately just put it on the line without having to do any work on the side, that's fine. But I do find a lot of students like to look at that off to the side. And so where you see x, you need to put in x plus h. And don't forget that plus 3. So that's f of x plus h. So that's going to go first. And so this whole thing is your f of x plus h. And the next thing you need is to subtract the entire f of x. And f of x is this binomial up here. And so it's minus the quantity. You have to subtract the entire thing. And that is all over h. So we have, there is your minus f of x. And now it's the algebra from here that you have to choose to delve into. For some people, it's easy. For other people, it is more of a struggle to get through it without making an error. And it is worth the time. Give yourself time to do it so that you can get every step. Because the answers are in Canvas, but it's not, it's not, well, I don't really know how they got there, but I'll just write it down and hope. No. Figure out how to get there. Ask your peers, ask me, come for a tutorial. Look up the difference quotient online. Practice the two from the examples in the notes, and then try to go back and do the homework problems. Because the homework problems directly parallel these examples 4 and 5. All right, so my soapbox, you got to learn to do it right in your homework. So we have a 2, we have a square of a binomial. Square the x, square the h, multiply the xh, and double, and you get a 2xh. Square it, multiply, and double it. When you square a binomial, you get a trinomial. And then we have that plus 3, and distribute the negative, and it is all over h. And continue. Drop down with an equal, have your fraction bar centered with the equal sign. I want the h written on every step. I don't care that it is repetitive. For this to equal this, they need to be over h. Don't be lazy. All right, and then distribute your 2. And if your fraction bar gets too short, extend it. Your entire expression should be sitting on a fraction bar. The fraction bar, it shouldn't be hanging over on either side. And a good sign you're in the right direction is everything that does not have an h cancels. And I want the step where you show me what was left after those canceled. Now don't get cancel happy. You cannot cancel these. You have addition of terms. You have to be able to take out what you want to cancel from both terms. And so that means if I take out an h, out of both terms, now I have a product of terms. And when I have a product of two terms, I can cancel. And my end answer is this 4x plus 2h. Notice it has a variable in it because the slope is changing on a curved function. So you don't get a single numerical value. And so that is your difference quotient result. Again, 4 and 5, they're paralleled. You do the same two types of expressions. So use these to help you know what the algebra is. All right, and then I added in a sketch, a graph, because people they struggle with these, and I get it because it's the first time you've kind of gone back and given all this information, graph something. All right, so the domain is -1 to 4. The range is -1 to 8. I'm actually going to map that -1 to 8. -1 is solid, and 8, 1, 2, 3, 4, 5, 6, 7, 8 to 8 is solid. So I've got to make sure it doesn't go below -1, it doesn't go above 8. And then I have where it's increasing and decreasing, so I suggest that you draw a number line, and from 1, that's not -1, from this one, 2, 2, 3, 4, it is going up, it is increasing. From -1 to 1, it is decreasing. From -1 to 1, it's decreasing. So that notation tells me as I'm going from left to right, and that's the entire domain, -1 to 4. So I'm going to start and then go down until I hit the value of 1, and then I got to turn and go back up to 4. Keep on going up until I reach the next value of 4. Now, there are some things that don't move. X-intercepts are 0 and 2. Those are fixed points. They can't move. And the y-intercept is also 0 because the x-intercept is 0. They're the same, come from the same point. And then we have where is this positive versus where is this negative. And from -1 to 0, it's positive. I'm just going to put a plus sign because it's shorter. And then also from 2 to 4, it is positive. But in between 0 and 2, it is negative. And then you got to piece all this together, and you might not get it correct the first time. You just might not. So the domain starts at some point on -1, and since it's positive there, it's above the x-axis. I don't know, so maybe it's arbitrary. They didn't give me a value. All I know is that I can't have it start up here because there's a restriction on the range. So I chose up at 4. Maybe I could pick up at 6. It doesn't. You can have different answers. But it decreases until you hit a value of 1. And you have your zeros, and at 0, okay, I'm not going to draw it completely correctly, so it's got it at 1, it has to be bottomed out, and then it starts increasing, and then it's got to go up until you, at some point, hit 8. But now we've got to take care of a couple other things. The range only allows you to go down to -1. So I've got to come back and change this up so that in between these, it's negative, but I'm going to hit 1, -1. And that's going to be a point that is your minimum. So it's decreasing from -1 to 1. It's positive, -1 to 0, -0 to 2. It's increasing from 1. However, I need to get all the way over to where x is 4. And I need to get to 4, and I need to get to 8. So I am going to circle that point because it's not part of the domain or range values, but it's up to and including. And so as it increases to that point, there we go. Now I've got, I think, everything checked, that it agrees with everything that's there, so I can go back and fill it in. And that is the process. It's not you get it all right the first time. You got to go back and do some checklists. I think students have benefited from drawing these below to kind of remember to keep it all there. Marking out range, domain. There you go. That's it.